Good evening. Nasi kuin to gudu ngarang gi kenoni lemhover rolling motion and then rotational motion ngarang lotion get over the question kara what hore do question kara doina solve to dragadi no understanding ID knowledge gap amale horani eduna adu solve to aduga hayeng gi test ta akoina gravitation gi part 1 and haveneba ko but gravitation jam chaw chapter na tabnina ai dum gravitation lawthoge aduga next class the gravitation ga experimental physics ka club tawge ko hanagi plan dusu gravitation ga experimental physics ka club tawbani next test ta but portion kharadi habidi Kepler's law gumba and then acceleration due to gravity at a height at a depth adudu handaki test da hapkena plan toromane ko but again next test adum hapage kay di aina adudu cover tawsaluragadi question yam solve tawba nang roiba ko na question marang kaina solve tawbudo sir gi main oiba target na question yam solve tawrigay angang sing dasu understanding level he level ko theory katang ka pangtag taga question solve tawdragadi noida kayni gap khar lay legal student gay ko aduna question noina kram solve tawba na ko dan kan mani so let's start today's class. So sila and ako ngarang to give the rolling motion gi ka sisi to give ni duga inangarang to give to sisi was the si to do ka no that's okay I can just lay 1 second. System of particles in rotational motion man quick kadai bi over no kandre all right fine so let's start let's begin today's class. Kung ngarang solve to give to sige questions go solve to give ni ka. Do makha do solve to or si. Sige sibuk to give ni. So question number 67, 68 si ngam gadrang moidra. Question number 67 sina higher is can have a wheel having moment of inertia this about its particular axis rotates at the rate of this about this axis. The torque which can stop the wheel's rotation in 1 minute would be and I have a car. So it's very simple. I have at him pige. This is the first question ko. Yam live question ni. Duga makha si skip to whether to read yung si ka. Si kasi mo di kino to whether ni new in to ka. Ano ba mo hangin na traga ni nuaro. But again, medyo mo si formula si recall to whether mo ay kita. Nuaro din nila. Anyway, fine. Yeah, not an issue. Alright, yare ka. So, how is it? Aduna kay lay hay matamda kuina sige sida kaino a wheel having moment of inertia I pyramid ka I pyramid I is equal to harga 2 whatever kilogram meter square and then it's rotates at the rate of this so omega is equal to 60 into 2 pi radians again per minute never ka divided by 60 among to 60 into 2 pi so radians per second so do the 2 pi radian per second and this about this axis ka so the torque which can stop the wheel's rotation in 1 minute and then kay mo pyramid is times kay 60 seconds pyramid ka so adu regadi torque putho hay ne adu di torque ti kay I alpha ne ka aduna alpha na putho ki si alpha di kay hay matamda final di 0 ni initial na 2 pi ni and time na kay 60 ni ka adu regadi kay tare have the pi by 30 tarba minus pi by 30 tare adu regadi the torque is equal to I alpha so 2 into minus pi by 30 hai tare ka so adu regadi kay tare ni have the minus pi by 15 So minus 2 budi keno lejare ko. So pi by 15 is the right answer ko. Ma'am, tabre yung sige se. Si tabra. Kenom to toro. Check am to toro. Kay gini yung pinchang ini matam.
Tayo, sir.
Tayo ko. Okay. So sir na solve to isi. Sir na solve to isi. Gyan taho bra.
Oh, tayo siya.
Tayo ko Prithviraj. Nikhil tabra. Cheta dum ko manche ko. Lakshmi tayo ko.
Tayo, sir.
Tayo ko. Okay, fine. So Nikhil. Tayo sir. All right, great. Now, next question is question number 68. The moment of inertia of a body about a given axis is this. Initially, the body is at rest. In order to produce a rotational kinetic energy of this, an angular acceleration of this must be applied about that axis for a duration of what time and time never ko. Sisi no ingam gadra ngam moidra. Sir na solve ro. Haro sir. Ngam ni ngam moy or sir na tawzira.
Tayo siya.
Tawzira ko. Okay. So the moment of inertia of a body about a given axis, I pyramid, I is equal to 1.2 kilogram meter square. Initially, the body is at rest. Omega naught is equal to 0. In order to produce a rotational kinetic energy, half I omega square is equal to 1500 joules. An angular acceleration of 25 radian. Alpha is equal to 25 radian niko handang mukti. Revolution na ko si checksel ko must be applied about the axis for a duration of the t is equal to what? T putwa na si myam natra. Adu iba taragadi akoina kay khangi matamda alpha le I le ko omega naught square le. So adudi magi kay do what total energy se ko CC ahmad 0 never ko and then final energy sina CC never ko aduga I alpha di talk le ko talk and then atopa kai pyramid have the omega pyramid omega putuk pe are ko adudi alpha di khange kem kai de the t putwa never ko. Why don't I use this formula? I guess I'm the chang do man de t putok ko T is equal to have the V minus U omega minus omega naught by K na A na tra A the alpha. So what is omega? Omega di kamay putokani si day puto over ka si dagi. So kamay na putokani have the omega is equal to 1500 into 2 divided by 1.2 haraga square root la ani buka. Adu haraga di kay na have the 15 to the 30 le ko and 0 of the 0 mapsalo and then 12 toro adu gadi kay na kaksige 6 na kaksira 6 to 12 6 5 30 and then 0 ko so c0 humle si pura kano ni ko root over ni adu gadi 22 na ko so buta gadi again Sigi 10 naman logto adu di si 10 naman ka credit 2 na ka credit di 5 ang pang F so 5 5 2500 lere ko 2500 or agadi 50 tare bo omega se ko ana adu agadi kuina kido we have the 50 minus 0 divided by 25 adu agadi 2 second 2 second tabre mo me amta yung ta tabra
Tayo, sir.
tai ko so CCD yam live question ne ko moina I is ko chang bro I chang de ko I chang ni keno dagi ko si dagi I sang ni alpha su chang bra alpha su chang ni I sin ne ko loin si ne ko okay yare so yam line solve to gre ko Prithviraj ka nikhil ka di kyan tahu bra
Tayo siya.
tahu ko yare ko okay nikhil su chetam kung pe So angular momentum in case of rotation about a fixed axis. Now no isigi matungi question kai gumba lairaga su sir kano ne question yauri hanga ke haraga dum tharo sir da ko sir dum haji dum solve to ke ba. So yengo no question yaubra yauri potuni am lairaga di hanga to yare duga no nga moy khalaga di hanga. So question number 69 the haji can a solid sphere is rotating freely about its symmetry axis in free space. The radius of the sphere is increased, keeping its mass constant. Which of the following physical quantities would remain constant for the sphere? So no hero si kisi kayuini. My mass constant orga magi kayumba magi kaheni radius to ka. Adu sum hengalakpata arga di ka. Adu arga di kedoro kani have the magi mass distribution the further and further away from the axis of rotation or kanina. Which of the following physical quantities would remain constant? Again, first angular velocity. Angular velocity si taptharakani ka. Moment of inertia hengalakani, mass laptharakani, rotational kinetic energy taptharakani, angular momentum constant lakani. So option number D is the right answer. Gyan tabra tadabra. Tadre.
Sir.
Taika. The mazi have the again free free space name free space have the absolutely net external to nung kai kam ta leibia de ko aduna my mass to kai guma do na spread out over hela gadi moment of inertia angle kaneva and angular velocity di ke dor kani tap thar kaneva rotational kind energy tap thar kaneva ko and angular momentum di ke dor kani constant adum lai neva yare ka have the I omega ne ko aduna I du hengalakme omega da handarakani omega da depend to eba a ga c ga je aduna c change la kani sina I da change to sina I da depend to eba I hengalakani ba but ani du product to the constant no ni ba I into omega da ko kai no angular momentum have c net external to later di hong be adeba. Question number 70 yango. Two disks of same moment of inertia rotating about their regular axis passing through center first passing through center and perpendicular to the plane of this as angular blah blah blah. They are brought into contact face to face, coinciding the axis of rotation. The expression for loss of energy during this process is yam live question ni answer ure do noi ngamgadra ngamoidra sir na tawuna pabra hairo. Question number 70 is
C, sir. Conservation of angular momentum. Pandra.
yes, very good. Conservation of angular momentum pan gadoy.
Oh, sir.
Ngamgadra hairo
Sir, yeah. Namni, sir.
ngamni buka. Okay, Prithivira sam ngamane. Lakshmi, question number 70 is sir na tawzira natraga yadra.
Yani, sir.
Yani buka. Okay, fine. So CC kanone buka koina translational motion gi the collision do aduga chamane CC na rotational motion gi da collision gum bane ai this ani rotate or le ani thengai na re buka thengai na matam da di ke done matam da net external to kem ta leite ba aduna total angular momentum du constant oi gedam ne ba aduna I1 omega 1 plus I2 omega 2 is equal to harga I1 plus I2 omega another lak dine ba. So adugi dudagi have the have the kinetic energy di have the half harga half I1 omega 1 square plus half I2 the half I1 plus I2 omega square minus half I1 omega square minus half I2 omega 2 square and adu to dine ba. Yan tani taroi tabra sir na high grade kumaktre gyan tahudra taya Prithviras Lakshmi
Tayo,
gyan
sir.
tahawe ka okay Nikhil tai ka okay yare. Question number 71. Two rotating bodies A and B of masses m and 2m with moments of inertia this and this have equal kinetic energies of rotation. If this be their angular momentum respective then so question number 71 jing amgadra sir na tawzira sa haro 71 je Kumaktre. 71 से ngamgadra ngamoidra tawzira yadra kaigino kem kumaktisibo. Question number 71 se yaradro sir na tawziro
Yani sir.
yarni buko Lakshmi gi
Yani sir.
yarni buko
Okay.
okay ataidi
Sir, yarn.
Prithviras okay Nikhil di kaigino yang kuin chang ni natra noi ji question pairo. So question number 72 question par gusu yang kuin chang man gripe khada dwa adu yang kuin ni chang di yar. Two disks are rotating about the axis normal to the disk and passing through the centers of disk. So disk D1 has 2 kg mass and this radius and initial angular velocity. This 2 is this. The two disks are brought in contact face to face with their this angular. Again, this is chamane. Kano ni this collision gumbani kong asagi question dugo chamane. So this is no ngamba muli thwe do no adum yadra. No ni yaroi khalagadi haro ko sargi motadi question like dida. Tawzera Prithvira. Tawza.
Tawzera.
Okay. Hajikido tawza hagadi no question number sigi 2017 gi dikeda way tawza hajiba. Adu adi question ni chamana yi. So since the two disks are rotating about their axis normal to the disk and passing through the centers of the disk, this D1 aham first disk is 2 kg mass. So magi I1 moment of inertia I1 is mr square. So 2 into araga. Okay, so sidale is have the two disks are rotating about the axis normal to the question so first disk ki moment of inertia is the disk nina mr square by 2 ne half mr square ni ring or mr square so half mr square. So C sumain layer ni buka C kakrani 224. So 4 by 100 thumb gira 0.04 gira yare. And this two gi moment of inertia duna kaino have the so I2 is equal to half into this two gi mass 4 into 1 by 10 into 1 by 10. So C2 C4 zika di 2 tare and 2 by 100 tare ka. Now makayeng si and initial angular velocity CI1 and then omega naught 1 is equal to and initial angular velocity 50 radian per second. So 50 radian per second and omega naught 2 have the 200 radian per second. The two disks are brought in contact face to face with the axis of rotation coincident. The final angular velocity of the system is very simple. So final angular velocity of the system is I hierarchy. We have the I hierarchy. I1 plus I2 times omega. I have the moini common omega. Adu kai gamanani have matam danga sagi I1 omega 1 plus I2 omega 2 do manane. Adudi omega puthoke haragadi kaitani have matamda sigisida I1 omega 1 plus I2 omega 2 to the I1 plus I2 na yengadine buka. So adurgadi 50 I1 omega 1 di kaino 50 into 2 the 100 so 4 by 2 the 2 plus see 200 na see 32 to the 4 divided by harga I1 plus I2d 4 plus 2d 6 ko 6 times 100 tarni. So 456 adudi 100 tar ko amte yung ne check to 100 tabre yung
Tare sir.
tai ko. So
Tare sir.
okay fine yeah thank you. So kaya to easy sir na solve to easy gyan ta hobra
Tahu sir.
tahoy ko Prithviras. Okay. Lakshmi tahoy ko.
Hoy sir.
Nikhil Chetakume Taeka. Okay, fine. So sisu kenoni ko yam live kenoni yam live question neta. Si yam chauman jawan eba. Now see assisi niko initial angular momentum I1 omega 1 I2 omega 2 is equal to final angular momentum. Final the moini si punna uminram ni na common omega am down I1 plus I2 la ni ko. So that's it. Now sige sige na doksan gravni tois. Ko berani tois. So Kadaya Ugresikito. Okay, so question number 73 to within a circular platform is mounted on it is initially addressed a 50 kg man stands on the question number 73 is if a start of the car. I know for the question I didn't know the kitang tough for be. So, a circular platform is mounted on a frictionless vertical axle. So, vertical axle the circular platform mount or this is the vertical axle, and then so yeah, we have the circular platform and its radius is 2 meter. My radius r is equal to 2 meter. And its moment of inertia I is equal to 200 kilogram meter square. It is initially at rest. Okay, so omega naught is equal to 0. A man 50 kg, a 50 kg man stands at the edge of the Nupama Shidalepe and begins to walk along the edge of at the speed of Nupa Sigi Magi Sumain Chatpagi Magi. Velocity do tangential velocity to 1 meter per second ni adu target the relative to the ground I have an so okay fine yare with respect to ground within yare so do get the time taken by the man to complete one revolution questions yamna complicated or shall see questions so anyway we'll solve it sigi sida koina kai khanga do have the quite first si pochi nupa du this is rest layer me auna initial angular momentum total angular momentum 0 ne ba the final angular momentum zu 0 adum ta ga da ne ba ko auna angular momentum zi ngasai gi kanagi angular momentum no have the disk angular momentum di kaino I omega should be equal to the angular momentum of the person ka sigi hadi person sigi angular momentum di kaino m b n r okay so this kidi kaino have the 200 into 200 into omega okay so this ki ka angular velocity duni adu du kai tani have the m di kaino person gi mass piram 50 kg piram ka person gi mass m is equal to 50 kg ne ba aduna 50 into velocity 1 into my radius di kaino 2 so it implies omega is equal to 50 into 2 di kaino 100 by 200 which is equal to half radian per second. Now half radian per second this is the angular velocity of the disk never or of the platform never. Can I guys have the platform dugi momentum duga person dugi momentum duga ani du kaidoni hamatamda have the net angular momentum 0 nina ani equal and opposite way but moigi equal and opposite check my vector the equal and opposite has a 1 equal my magnitude equal to never gyan taita de have the angular momentum of the platform hydra or this hydra plus should be equal to the okay, do we have the angular momentum of the main neighbor ko kay na net angular momentum 0 neighbor ani is equal and opposite in negative neighbor amana sigi direction si leragadi amana sigi direction si lay neighbor ko aduna kay no race lay banina mana hek chat pa hor ko matam this to opposite side ta hadi mana ne sumai nek chat pa hor bo marak matam this to sumai chat loiba man som chale na this to sumai na punna samina roiba mana sumai nek chat pa hor matam this to mai tunglom do in salakani ko sinoi thengnaramani dum mai di game kai ka ama na tragana hajikan fitness ki kai kai no ai maming ka kaugre kayani something race to na bodo makan na the obstacle myam lan bodo of the fine circular disc taga fine chat pada queen so mind chat lagadi disc to na opposite direction da salak pada ko adugi type tani so aduna adugi potu sidagi ne ina lauri se ko gyan tai ta de gyan taram da na ina so
Sir, Dix ka
Hi,
puna
sir.
sa minadura.
kay ba
Dix ka puna sa minadura ba kano ka? Midu ka.
natiye keno ne buko sir ko sir herkes karino ne this siga mi siga sanmina dura hangira rangiza
Opposite direction ta.
yes opposite action
Ah.
chakani
Oh.
kay you know ay matamda for example habidi mana sigi this race le mas race le haji total angular momentum z moini zina scam move to how doing initial angular momentum 0 never now nupazin x from the set power kumatam the this city asom direction chakani nupazin asom direction chakumatam gyan taita de
Tara sir.
tai ko adu one ever ko adu aina lege duini aduna still total angular momentum 0 takadam ne kay si externally mi kananong pair ga push to ko nate ma masamuk su si the yaw na system ji manung da maga disk ne ba laminate maga platform do na platform na direction am da rotation to ho ragadi mana opposite direction rotate to bo gi ne ba ko platform na mana clockwise le platform na anti clockwise la ka ne so da into na si na platform gi angular momentum ni adu si sina person dugi angular momentum ni akoina minus half is always vector or can happy ko vector with the half te ko vector natural just magnitude when the equal duni aduna swine through omega putu e ko now sigi omega si kanano nga sagi platform dugi magi omega du neba now adudi ke do yam tam the certain with the relative velocity ta ki bido velocity and is opposite direction or kan the yam yang e ko sorry relative velocity is the opposite direction or kanda ke do we plus to weba ko aduga we add the magnitudes of the two velocities if they are in opposite direction and we take the difference or we subtract the lesser from the greater if they are in the same direction now abdi magi person velocity with respect to ground with respect to ground 1 meter per second aduna sigi v is equal to haraga kaidoni hamatamda v is equal to let's say 1 meter per second 1 meter okay see v equal to 1 meter per second for any now let's say omega see omega of the platform so omega of the this win this percent p is percent d win friction circular platform would high but it is in the form of this platform main the platform main okay so cp ni hierarchy ko cp ni see the velocity of the person again see with respect to ground ni ko magi actual velocity nate so omega of ngasai gido kedo ba v is ngasai v z kaino have the omega r ne natra mani ko adu ergadi it implies b equal to omega cross r ko yes omega r le ko adu the time taken by the man to complete one revolution and I have never and duna omega by omega di v by r le ni ko adu di v by r which is omega with respect to the CC kaino, this is with respect to the ground niko. Relative to the ground hai tare. So with respect to ground hai. CC kayo ini hai matamda omega with respect to ground see the sum of the two angular velocities hoineba. Angular velocity of the platform plus angular velocity of the man hoineba. CC gyan tabra tadabra. The person dugi velocity ga main dugi sorry platform dugi velocity duga main gi velocity ani equivalent adi ani opposite oina banina maoini gi relative velocity du plus la kani buko aduga adugi plus to adudu velocity with respect to ground oidineba gyan dai guys ya habidi net velocity do moini gi sum do la kaneba auna v di kaino v di 1 and radius di kaino radius di 2 is equal to person की velocity kaino omega p platform की half okay and kedaba angular velocity of the man piram de ko so aduna di kedoni have the like is there anything so time taken by the man to complete one revolution and okay fine. So this is omega tareba. Omega of the man. Now, I the this is time taken to talk about one revolution gika aduna this is yen ka. So half cancel sakre omega of the man 0 taiji kamain to kai sure. Uneasy relative velocity relative velocity v by r. Okay, fine. Kem kai de. Person की velocity is 2 by sorry 1 by 2 is a radius atra mane person की velocity is half and then relative into is square cc person की का magi velocity si kayo ini have the person की velocity is mana c with respect to ground atra mani not with the omega with respect to ground C platforms with respect to ground okay fine yare not with respect to each other niko adu this is half of them tar ni buka aduga C is in a net velocity of the net resultant velocity ta de omega r devuka aina khali chumra adu di 1 na kaigumba time taken puto care gadi 2 pi divided by 1 ka aduna 2 pi second tabra sige ja yung nem 2 pi second tabra to omega tai ka okay fine adu this to chum ka aduna kaidawi hamatam da sigi moini gi haziki nupazina chatkadu si kaino habda magi on velocity ze sida chatta unate ba aduga hadi platform jina jo opposite action chale on net resultant velocity do or relative velocity do adudu da chatkadu ne ba auna sigi pot si na kamai have the again b equal to omega r si budi yare so sigi ai sigi mota sumaino in na ko yeah sumaino in irake ka adu regadi si omega p le na ka aduna omega r relative velocity though that it will be equal to omega p plus omega m. Is it? Yes, omega m ka. Since omega p n kedaba omega m are opposite yare ko aduna moini gi relative velocity sum tawni ko opposite wargadi auna omega p gi di half tare and omega m gi di kaino ha matamda omega m main gi di kaino have the v by r so v di kaino 1 and r di kaino 2 on half plus half di kai tare which is equal to 1 therefore time taken by the man to complete one revolution time di kaino have the distance with theta ni ko So theta by omega neva. So theta di kaino 2 pi, and then omega di kaino omega r hai tare ko. So omega r di kaino 1, which is equal to 2 pi second. 2 pi second ta hai dai sig is. Yeah, ko sa.
Yes, sir.
So mine solve to go do ni ko. Let's say this is the main gini. This is in a main gini, and then this is in a platform. Do gini ko an easy opposite oina go do ni. So it's a very interesting question. Question for Z. Yeah, so okay, fine. Yeah, so ma'am, can to bra? Yeah, bro, ni maksi kiza.
Yeah.
Okay. Nikhil di yarba. Chetuku mazi ay ka. Okay, fine. So let's move on to the next question. Question for the question si TikTok soluka. Noigi sigi question jida. Moina sida yawriba concept si kaino conservation of angular momentum ama yawre and relative velocity ki concept am yawre ka. Opposite direction chana baina you have to add the two velocities in order to get a resultant or relative velocity ka. And then adugi velocity do da akoina angle the adu velocity yela kana time phangni ko. So adain to hot kadene. So it's a very nice question. Question yam fazi. Next question number kya no jigda 73. Next 74 da kaino. A circular disk of moment of inertia IT is rotating in a horizontal plane about its symmetry axis with a constant angular speed disk. Another disk of moment drop coefficient. The energy lost by initial rotating disk to friction. Again, it's a very simple question. No, yung question number 74 is ludo malaga di search solve to ko. 74 is yung aduga hydroxide. Ngamning ngamoy. Lakshmi yi makhun tapman dana sir kem tadrebo. Lakshmi.
Sir.
Tawzeba ko. Okay. Tawz. Okay, fine. A circular disk of moment of inertia IT is rotating in horizontal plane about its symmetry axis with a constant angular speed omega I. So another disk of moment of inertia IB is dropped. So adurigadi kaina have the koina kai khangi have the angular momentum je constant oigadeni na ko initial angular momentum je kai tai have the yang si kaina tois. Auna koina I1 have the IT omega T plus another disk of moment of inertia IB and omega B hai tare ka. Okay, omega B is 0 ni ko initially the IB into 0 hai tare is equal to both the disks rotate with the constant angular of the IT plus IB and then omega F final. Adu with target the you can find out omega F. Omega F is equal to kai tare have the IT divided by IT plus IB equals is times omega T. So this is your omega F. The energy lost by the initial rotating disk to friction have a car. The energy loss delta E put okay haragadi and see the potential energy room came later. Here energy has a have a this will be kinetic energy the moidinica rotational potential energy room came later. So the energy lost by the initial rotating disk to friction. How the initial the kaino have this amakatang never rotate or music aduna adudugi kaidoba energy loss puto haimneba adudi half haraga it haraga omega t square minus half haraga it by it plus ib times kaidoba omega f whole square or any buka. So which is equal to half it omega t whole square minus half ICC whole square torakadunico. I need to chumbra omega f puto have natural shimakalanica. Okay, fine. Omega t. How the kakna drainage the kakna bum the top drop. Can on this forever. Cube line is there. Cube the lining there. Is there any mistake? It omega t omega f level omega t in terms omega f in terms of omega t the e get moine is kind of omega I have a omega t have but again omega t omega I money in lower natragana koi low toxira omega I count. So this is omega I, this is omega I, and this is omega I. Half RT. This is the kedoba. How could the labor kinetic energy, the initial kinetic energy minus final kinetic energy never. Omega F never. Now omega F in fractalize. I have 1 omega 1 I 2 omega 2 is equal to I plus I 2 omega. Makala IT by this omega I.
Sir.
Haro.
Minus half IT plus IB khắc ꯑꯣꯏꯒꯗꯧꯕ ꯅꯠꯇꯕ꯭ꯔꯥ?
Minus sigiza half harga IT plus IB hara. Oh, 2 minutes. Aduni I sir na kind of I see on a comment to Mr. Thank you, Lakshmi. CZ IT plus IB right. You are right. I need comment to C uraga C wakanji kale half MB square in a half I omega square again. Very good. Thank you, Lakshmi. Audi has CC where Amina has a kidoni Amado square lak with the Kailani have a da. IT adum lani ko mathakta IT lani aduga IT plus IB lani aduga IT square legadra habita yenge ko sisida omega f whole square in IT square by this ne IT square lani and omega I whole square lani chumra in has chumba malika IT square le aduga asomdana silayuka. Okay, fine. Kaide. Adu orgadi, which is equal to haragana half common low omega I whole square common low audi IT square minus IT IB minus IT square CC plus nebuka divided by IT plus IB tare. Adu evitaragadi kaino siga kakre aduna kai tare option number CC tarba ITIB 1 by 2 ka omega I whole square. So option number D tabra on tabra. Taika. Okay, fine. So moina IB IT hare then IT plus IB hare then omega I whole square ka. So this is the right answer. And it's a very simple question ka. The yung hajik atang with the myth alay. How?
Omega F की value 신jelapay matang.
Omega.
Adun have you half
C.
house.
Okay. Nang sige kitang arba. Okay. Sir, okay ka. Step am okay. So sige C aina sige buti. Isi learning ka. Duga. Sige pot C aina C sita. C hapani. CZ C sita hapani. And then to the square learning. and then see the square line. Yeah, we want to.
Yeah, that.
Yeah, so okay, fine. So Nikhil the arba, Nikhil tae sir. Okay. Shall we move on to the next question?
Yes, sir.
Yes. Okay, fine. Question number 74, 75. A thin circular ring of mass m and radius r is rotating about its axis with constant angular velocity omega. Two objects each of mass m are attached gently to the opposite ends of the diameter of the ring. The ring now rotates with, again, sisu conservation of angular momentum panga. Then sisi haigadra hairoidra hairo. Saja hairo.
Here.
Hairni buka. Kai tane hairo de.
Sir, B नत्रगा D mal.
Okay. Quite first, this key kedoba magi the angle now rotates with angular velocity at the my omega put for m buka. Auna kedoni have matamda is rotating about its axis with constant angular velocity omega. Adirga the m haraga magi initial angular momentum z m omega square tare buka. Is it? No. M r square omega square tare initial angular momentum z. Adududa mass amazigi amka mr square m macha r square m macha r square na adudu plus total angular momentum layena. Auna adududagi equina angular velocity putoke haragadi common oiba ngasai gidu putokadu. Adum noisi again yam lai noisi sing amgadra natraga sir na tawzira. D tae na hai. Okay, fine. Tarambe. So we can solve it. But noisi sing amadra tawzira sa zairo.
Sir, mathang tawar.
Mathang tawar. Lakshmi ji arbol. Lakshmi. Yeah, name buka. Okay, fine. Question number 76. There. Round this a moment of inertia I2 about its axis perpendicular to its plane and passing through its center is place over another this final angular momentum of the combination. Irai lai ko sidi kai tagi ngasai gida. Kaugraba. Sida kaino da tawib kai chakra si mamang kai da. We hoti hot kada si chapmana ba ma. Kaino akoi 71 si tawgidraba. Haini have ni ka. Do this rotating about its axis. Internet is kitang unstable oi. So sig is the tawgib do chapmana do ni. Anyway, question number 76 am gudrang am sir haro. Kumdre.
Namni.
Namni buka. Okay, question number 77. 70. Okay, good. 77 GD. A thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. Four objects, each of mass m, are kept gently to the opposite ends of two perpendicular diameters of the ring. The angular velocity of the ring will be see again, sir, I have the moment of inertia as a scalar quantity, so you can just keep on adding. You can add the moment of inertia due to the new masses and you get the final moment of inertia and the final angular velocity. What you have to keep in mind is the angular momentum should be constant. The net external torque angular momentum constant. Question number 78. A disk is rotating with angular speed omega. If a child sits on it, what is conserved? Conserved linear momentum conserved oiroi. Kinetic energy conserved oiroi. Angular momentum oirni ka and potential energy oiroi. Potential energy di kemtable laite ka. If a child sits on it, adu oibataragadi kaidongni ha matamda magi omega taptharani omna linear momentum taptharani kinetic energy taptharani dagi magi potential energy di we have the laite. Potential energy has no scope here, so angular momentum will remain constant. Question number 78 here, Adra ma'am. Okay, so ako sir nangarang rolling motion ki formula derive to give do ningsing iba kamaya ningsing do you know have the ngasagi magi velocity do kaino root over 2gh to the my velocity tapthara ko divided by 1 plus k square by r square ogadiba aduga my acceleration na kaino z sin theta divided by 1 plus k square by r square oigadeba aduga magi time na kaino 2s by z sin theta ni nako my time taken the alda kaidoba time taken ni hengala kaduni 2s harga 1 plus k square by r square divided by z sin theta oigadeba gyan tabra sir naija formula du kamaina recall to gudoino do active recall haigadra pau phonai founde
Foundation.
Okay, fine. So, rolling motion, the edges of radius 2 meter in mass, 100 kg rolls on a horizontal floor. Its center of mass is speed of this. How much work is needed to stop it? Again, see the horizontal plane of the roll the way. So, magi kinetic energy do initial kinetic energy see put ho final kinetic energy di zero ni aduga kaidoba magi work done di kaino how much work done again work done di do tayo na ka. So just just find the kinetic energy. Sisi ngamgadra ngamoidra sir tawzira sa zahiro. Tawzi haro yani haro sa zahiro.
Yani sir.
Lakshmi
Yani sir.
yani Prithvira so yani Nikhil yani ka. Okay. Next question je question number 80 2019 ka Orissa NEET. A solid cylinder of mass 2 kg and radius 50 cm rolls up an inclined plane of angle of inclination 30 degree. The center of mass of cylinder has speed of this. The distance traveled by the cylinder on the inclined surface will be s put however. So it's a very simple question, but sir tawzira simadi
Tawzi
tawzibaka. Okay, fine. So matam jisu zer long zeli ka kangudi matam si. All right. Okay. A solid cylinder of mass 2 kg and radius 50 centimeter. Rolls up an inclined plane of angle of inclination 30 degree. The center of mass of cylinder is spit. Let's say this is the cylinder. The cylinder ni koi na di som da yeng di magi area of cross section katang ure ka. So 4 meter per second center of mass. My velocity is 4 meter per second. The distance traveled by the cylinder on the inclined surface will be. So you have to find out the distance s. S you never put wise. Okay, fine. Now my mass in 2 kg in radius and this. All right, fine. Okay. Now, noi sigi sida kamaina puthokani hai matamda noina magi velocity se magi velocity se kaino hai bata the distance traveled by the cylinder on the inclined surface. So the mark kam san na chatke hai bane bako sigi sida can tai kai ja adu ergadi initial velocity is in a v le final velocity is in a 0. So and s is equal to v square minus u square by 2 kaidoba 2z sin theta. Kaigina again this is the minus never ka minus 2z sin theta tha. Is it minus yakado yaroidra expression z sin theta ka somdagi sumaina magi mass hai di suppose soida le enkal jeba this is z ni da this is z sin theta ne ka this is z sin theta then ma z kena to la kena tapala kena rule 7 has a speed of 4 kem kai dega so v square minus u square So V d 0 square minus harga 4 square d 4 into 4 minus 2 into Z d 10 sin 30 degree di kaino half natra. Aduraga di 2 ga 2 ga kre 4 4 16 1.6 meter tabre ma'am. Option number B tabre. Taika. So yam live question ni ko no is the unnecessarily no complex o henganu. Kay yino hay matam da moina magi center of mass ki velocity piram banina magi center of mass to ako edu da kam yengaro center of mass ki velocity do horok pada initially si u ni ko si this is u is a 4 layer final di mass ko kakal race la 0 layer ni adu di s pu thoke di koina kinematic equation do sida lebe acceleration di z na te ko mathak ta langkhat pa na te ba sida g ki component mo idine ba na g sin theta idine ba ko so noi loina gyan ta hobra Pithivira star ba
tahu aja.
Nikhil tar ba Nikhil no response okay lala tare ba okay fine great now that's question number 80 yes question number 81 a solid sphere is in rolling motion a body possesses translational kinetic energy as well as rotational kinetic energy simultaneously the ratio of this to this for the sphere is it's a very simple question see noi sphere gidi radius of gyration nungama mata puthokadini ko so see noi haigadra heroidra yadra na traga start auzira saja kumo sat kumo pungje yaraktre keba Lakshmi ne have ta deva tauze hai na tra ta de tauze sir hai na tra yes or no
Yes, sir.
okay yeah okay sappe bu ko aduga kin to tang tap na ta ba dugi anyway fine so torzi kayin si chingya ji all right it's a very simple question so solid sphere in rolling motion body poses blah 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 kt kione kt ji ke no magi ka sphere is a solid sphere ni ka so half into m into v square so I can write this as half m omega square r square v is equal to omega cross r and cross to sine 90 degrees see there now k rotational is equal to half into magi omega do kaino I do half I omega square in a half I omega square so half into I gi mota aina kai lobi yai ha matam da magi di I do kaino solid sphere gi di 2 by 5 ka so 2 by
2 by 5 हो गया
5 m r square omega square so adudi kai tarni have the 1 by 5 m omega square r square aduragadi moina puto haisi kaino kt divided by kt plus kr adudi half divided by half plus 1 by 5 aduragadi kai tarni have the ccd 5 plus 2 is 7 and 5 to 10 so 20 by 7 into chum lalaba 5 ka sorry 5 to 10 yes 10 10 10 10 ni gino 10 by 7 haba 10 by 7 tare ko yarba ngawbra Lakshmi yarba
Sir, 10 ka may line.
si makala ni ko 5 to 10 10 by 14 law 10 by 14 I'm sorry
14 na siya.
5 10 by 14 ne ko 10 by 14. This is 10 by 14. So which is equal to 2527. 5 by 7 tawa. 5 by 7. Yare ko zikti. Yani. Lakshmi yarba. Gyan tawa bra.
Sir.
Yani ka. Prithviraj yare ka.
Yeah, sir.
So question number yeah, 81 here. 82 is again. It is a sphere of same radius but different masses roll off on the two inclined plane. Which of the two objects gets to the bottom of the plane first? So question number 82 start of geka 82z. 82z kind of the formula pa andoni ka upalite. You just have to apply the formula. Formula khang ragadi twe formula khang gadi lai. So kuina time taken ki formula du t ki formula du khang bra ningjing iba. Kaino 2s 1 plus k square by r square divided by z sin theta. Sina trakwing rang to give da. Aduna sigi pot sida kuina kedo we have the k is already auna t is directly proportional to k hatare ko. So heavy I auna kedo ni amatam da k disk k of disk ka k of sphere ga kanana heni radius of gyrations this na heni because aduna time taken du kaina this na hena changani. So t of this will be greater than t of the sphere. So this na helani this tabrium
Yeah, sir.
taiga cz r neba cz r neba ko and cg sina kaina sphere gidi 2 by 3r oibama or 2 by 5r oibama ani ji mak do r na dum chalbro sina 1r doing now over cg ja
No, sir.
now the Prithviraj. Lakshmi Gyantabra, Nikhil Gyantabra, Hiro. Tai. Nikhil di Tabra, Chetakumo. Tai, okay, fine. Now let's move on to the next question. Question number 83. The ratio of the acceleration for a solid sphere rolling down an incline of angle theta without slipping and slipping down the incline without rolling. Amana sitha rakpa amana kena. This is a question. Jita uzika. And it's a very simple question. Sisinu idung ngamni. Solid sphere. Acceleration ni ani di formula put hoiba ka. So ahambada a1 hage. A1 is equal to kaino kedoba sir nang sai give do a1 is equal to z sin theta by kedoba 1 plus k square by r square. Sisine m rolling down up and incline of angle theta without slipping and slipping down the incline without rolling. To slipping down the incline without rolling. Without rolling, it is z sin theta adam tazarena. It's a very simple question. I would the kaktanarnika. So more important is a1 by a2 put however. This sida yelagadi 1 by r or let's say this is r square by a square plus r square turn. So r square turn ki this kira solid sphere solid sphere 2 by 5 whole square r square plus r square. Aduragadi 2 square 4 plus 25 by 25. Aduragadi 25 by 29 current 25 by 29 yeah right that there kind of sorry. Solid sphere and hollow sphere. Solid sphere gidi 2/5 ni kina chumi. A1 by A2 na chumi kina. Si kakre. R square mata kakre. Okay, fine. Kem kaite. So solid sphere ki KD 2/5 R never gonna 2 square. 4, 5 square 25. So 25 by 29. 29 is a prime number natro kamaya din sila. Au nattabida aina kaygumba sumaina toromba taragadi. Sisi kakkimata A1 by A2 natro. Isamsamna 1 by 1 plus harga 2 by 5 R C whole square dum tadaw layer. 5 square is 25. 25 plus 4 29 by 20. 25 by 29 dum tayo ko. Kaya num suere sir exam ti yung kaya suere yung. Kaya suere nung gyan ta dito is. Kaya suere 2 by 5 ko. 7 by 5 or 5 by 7 is tari ko. CC. Oh, ay gyan tare. Damn it. No gyan tare ba? K is equal to kay no? K is equal to root 2 by 5 ni. Root 2 by 5 R ni. Gyan tabra. K square is equal to 2 by 5 R square neba. Root neba se. Si yung si. Sin takpadi practice what lam neba. Ay di sir di. Kano to orga later ni na ko. Ado no di soy biya dem si se. Ay si dum ko later ni na. Si kay no. Si 2 by 5 dum mo di neba. Yar ba. Gyan tay ta de. Tay ko. Ado orga kay ta niya. Si 7 si the 5. So 5 by 7 tabra yung. Tang bab to. Yung 5 tabra. Ado no harakti kay gino. Ay sir nga tang 2 by 5 to kano the club in local leme ko si root 2 by 5 root 2 by root 5 ane akoi mamang de soi gi de ko do en to uda yaw do male de soi ko aji ko wi di out luckily out dun ko yare. So let's move on to the next question ko yuna. Question number 84. A small object of uniform density rolls up a curved surface with an initial velocity v. It reaches up to a maximum height of this with respect to the initial position. The object is an ivaka. This question is Ludong man brush or them tausira sa Zahiro. Sa Zahiro. Kumagtre. Noing gudra? Tausivaka. Okay. So object of uniform density rolls up a curved surface with an initial velocity v. Okay, it reaches up to a maximum height. With respect to the initial position. Okay, the object is Sevaka. Okay, so Quina, initial velocity v, final velocity is equal, okay. Half it reaches up to a maximum height. Maximum height is 3v square sila ka. Then magi kano say mzh hai tare ka. Magi mzh is equal to half m v square plus half m half I omega square hai tare ka. Half I do mk square hai ka. And then omega square. See there, name ko. You can just cancel all the m, and if you want h, then h is equal to v square by 2z plus k square di have the k square measure omega di have the v square omega di v square by r square la so v square by 2z r square le now which is equal to v square by 2z si common lower gadi 2z si common lower gadi kai tani have the 1 plus k square by r square tare okay fine fatna bu fazari ni sidi now zik kaida we have the kaigumba sigi pochina 1 plus k square by r square zina kaigumba 3 by 2 my h mana so this should be equal to 3 by 2 aduna takpadi kaino have the 2 plus twice again I won't do that. I'll just find the k square. So the k square is equal to 3 by 2 r square minus 1. Is it? That's 3 by 2 r square minus r square hai tare ko. So 3 by 2 r square minus r square di kaino half r square. Sidi kaino have the 1 by root 2 r by root 2 tare ko. K is r by root 2 is kaino ring natra. Sorry ring nate kaiba disk oigadaba this natro
Analytics.
yung answer kay tagi yung answer kay tay
6 tay.
okay this adum tay ka okay fine Lakshmi kento bra yar ba gyan ta bra sige se tay ka dun cc na all right fine so let's move on to the next question 84 question din nung ay kalay solve ta 85 a solid cylinder of mass 3 kg is rolling on a horizontal surface with velocity v. It collides with a horizontal spring of force constant this. The maximum compression produced in the spring will be ICC. Sir Tauzira. Natraga skip Tauzira. Sazaro. Ngamgadra ngamadra. Sir Aro. Tuna.
Ngamni siya.
Lakshmi Haro. Tausi Hari Taudwini. Ka. Yani Hari skip Taudwini. Haro. Tause. Lakshmi ko taman nanta diba. Lakshmi question number 85 Tause hai netra yes or no?
Yes, sir.
Yes, sir. Okay. Hazikti am hore. Adwa hero ya drone sage. Okay. Tawrzi ko du dia. Aduna noi gi noi marak gi amana bu taw se hadim taw deni ka. And adum rotational motion adum gyan ta na ka tawrzi. Hengi test ka. Gravity do next chapter the next test club tawrzi experimental physics ka. So a solid cylinder of mass 3 kg is rolling on a horizontal surface, blah, blah, blah. It collides with the horizontal spring of spring constant this. The maximum compression produced in the spring will be have. This sumaina kamai yik cylinder se ka. Sumain torga ama solid cylinder ama blah, blah, laireva ka. So this is in a roll torga sigi spring. Let's say this is attached to a spring. Aduna sigi spring sida kaido ma thomjale thomjan matam da cylinder sina roll torga is the thomjale ka thomjan matam spring ji compressed torani ana potential energy stored in the spring the on gani total energy magi initial kinetic energy si kaino have the half haraga mv square plus half haraga I omega square is equal to half haraga spring in a kaino k x square tarni bako sisi gyan tabra sigi line ni kwai maru urje spring zigi kinetic energy translational kinetic energy ama laiduni magi ko kt am laiduni plus magi kv ama laiduni sorry kv as in kr have ko rotational kinetic energy do it will be stored as kaino magi potential energy of the spring hatare ko u potential energy natraga kai hajiga p hajra potential energy of the spring ani du mana gadam total energy se ko aduna do we have the half layer mass tk no 3 layer and my velocity initial velocity the 4 square 4 into 4 plus half into I tk no solid cylinder ni na half into mr square ni 3 into 4 into 4 into omega tk no omega the v square by r square so v tk no vd 4 into 4 oh my god is it yes I is no I see okay fine chumba maleka by r square v square by r piram the brane my jiba it collision spring okay fine r piram dev ko fazari kainom the problem on the lady anyway we'll see to that nothing to worry is equal to half into spring constant pyramid 200 into x square now see r is in a problem mass 3 kg is rolling on a horizontal surface with velocity 4 meter per second half m v square plus half I omega it collides rolling it collides with a horizontal spring of force constant this maximum compression produced in the spring will be in a heavenly ka adu half layer ka and then I cylinder gidi okay aina si 4 the r ne location given ni I'm sorry see the r square ma masai objagadam ne du ka takadam ne ko r square ite sumai legi da ka the answer tarmani the r square ka kreka and then c2 zina 4 the ka c2 omne more and c2 2 into 2 the 4 answer tarmani durgadi c2 zina si the ka di kai tare 100 tare aduna x square is equal to haraga 3 into 4 into 2 the 8 8 3 24 24 plus 4 into 3 the 12 divided by 100 so the 36 star 36 by 100 the x is equal to 0.6 star ba yarani ko si se yarba Lakshmi kumaktra
yarani sir
yarani ko Prithvi Rasi yarba
Oh, yani siya.
Nikhil yare ko it's so C question yung sa Nikhil na hang kiban ko okay fine. So, matang the question yamaktre ani hum the ngai ka. Question number 86 na is a solid cylinder and a hollow cylinder both of the same mass and same external diameter are released from the same height at blah blah which both roll down without which one will reach the bottom first side. So time ngasai gi do kuina we have the time taken z akoina my radius of gyration directly proportional oiba ka. Aduna my radius of gyration ji kanane and sauni solid cylinder ga hollow cylinder ne chawroidra. Kaino the hollow cylinder gidi 2 by kaino 2 by 3 ne because solid cylinder and 2 by 5 ne na hollow cylinder na chawdini na hollow cylinder will take more time gyan taita de kaino kram ko mukti je sigi gyan ta hobro ta hodabro
Sir, amtanga happy.
okay sir ne ngarang derive to give formula do to the time taken do kai tagi have the 2s harga 1 plus k square by r square divided by kai tagi z sin theta neva. Adudi obviously t is directly proportional to k neva. Aduna k of the hollow cylinder is greater than k of the solid cylinder natro. Adudi obviously time taken of hollow will be equal to time will be greater than time taken of solid natro. Chini sir nice. Ngorba.
Oh, tayo, sir.
Yare ko. Sila kada. Okay, nikil tayo na. Lakshmi di tarba. Lakshmi.
Tare, sir.
Tare ko. Okay, fine. Question naman ito nga 87, 88, 89. Kaya nyo ni. Question 96 po lang eh. Sasam to uzi kaya ano kita 86 na 87 amte yung chumri yung kita mata hollow cylinder ne na matam sang ni ba option number C tabre yung 86 no yung queen chang ay kumak ko da sa kumak ti 86 D ta kaya you know 86 D ta ja la la ba exact kaya no solid cylinder ne na matam sang ni ra which one is not which one will reach the bottom first time ni matam less sang ba da ba how the solid cylinder tare ko yare ko kumak tre
Oi,
amuk
sir.
kumak okay okay sa kumo na tay pung tingila ko tum to krajara na okay fine so next question yung is 87 a drum of radius r and mass m rolls down without slipping along an inclined plane of angle theta. The frictional force dissipates energy as heat, decreases rotational motion, decreases the rotational and translational motion, converts translational energy to rotational energy. Option number D is 87 ko. Kaino di frictional force lay benima rotation to ya is ko. Friction lay traga di rotation to or shit krani. So 87 is D ta ga ko. Yung yung kay ta yung 87 D dum ta re ko. So ajikitu gyan bu ta ho bro ma'am. Friction lay benima rotate to ya is friction lay traga di rotation lay ro. Pau phone na bro.
Okay, sir.
Next young
Oi,
question
sir.
waited. A ball rolls without slipping. The radius of gyration of the ball about an axis passing through its center of mass is k. If radius of the ball be r, then the fraction of total energy associated with its rotational energy will be in have a c. So you like ko. No idum to zero. Ngam gadra si kise. Question number 88 se. So zero. Ngam ni ngam mo.
Ngumni, sir.
Lakshmi.
Mami, sir.
Ngam ni ko siyeng ko. Okay. So Nikhil zung ngam ni ko. Try to ro. Nikhil kumo cheto ko. Next question number 89. A solid cylinder of mass m and radius slipping. What is the speed of its center of mass when the cylinder reaches its bottom? It's a very simple question. Sisi knowing ang gadra ng modra magi velocity ng sa formula panjalo dun taran. Sisi ng gadra ng modra sa zaharo ng mo hagadi sir na tawdo ni. Sa zaharo sige. Tawzira yadra. Kumaktre.
Mani, sir.
Ngamani bu ko Lakshmi ngamani. Prithviras sa zaharo.
Sir, ngumni.
Ngamni. Question number 90. Consider a contact point P on a wheel on ground which rolls on with this then value of displacement of point P when wheel completes half of rotation. Sidi nga modra. Sasa como? Tauzira.
Si, laya mara, sir, ngumni.
Live male. Okay. Lakshmi, CCD. Yadra.
Si tausi, sir.
Tausi ka. Okay. Tars. So only question 6 katanga ko. Question tarug ni. Loiram dai jani hin. Ay nga sa horok dabu isa kitang wawi tap taram ni question holo ga. Kaya to kale wawa ga pagre ko energy yaw kale. Consider a contact point P on a wheel on ground which rolls on blah blah blah. So do we target the basic kinatausi ka. Sige sita. Application. Compass. Okay, imagine. Consider contact point P on a wheel. All right. On ground, which rolls on ground without slipping the then value of the point P when completes half of rotation. Now let's say this point is P. Sigi point is P and colors. So now mazi half rotation set pamatamda. Kidoni have a matamda. Is half mazi half rotation again. Then half again. It will hardly make any sense. Then I'll just move it like this. So magi circumference mo chakadam ne ko circumference ki tangkai ta na si den si for let's say sumain chateng khala je ko hadik adudi point p zikai da lani have the point p zi mathak da lani p. So the C distance kaitarni, this is 2r. And then C distance in a kailani is in a pi r. Kaino di circumference ki tangkai na tro half neba. Gyan taita de. Lakshmi gyan tabra.
Aye, sir.
Q ni dana Q zi makala adam neba ko aduna si 2 pi r ki tangkai ni dana. Then value of displacement of point P है displacement of point P जे सीगी पोच सी distance पुट हुआ है अदुदी Pythagoras theorem पालो गए ना अदुदे यार बा so अदुना displacement S है this is S है S is equal to root over है pi square r square plus 4r square अदु है गदी नंगा r is 1 है देने अदुदी pi square plus 4 pi square plus 4 tar. Yan taita de taiko. Kay you know the r is equal to 1 and higher memory. Yarabo. Nikhil yare hare ko.
Yani sir.
Lakshmi yare ko.
Aye, sir.
Okay, next question number 91. A solid pair of resistors is placed on a smooth horizontal surface. A horizontal force F is applied at height h from the lowest point for the maximum acceleration of center of mass. Which one is correct? And I have a call. So CCD. Force to kai the P bana khwaidagi henna mazi keno tawgani for the maximum acceleration of center of mass. Maximum acceleration of center of mass le hen gaya the force to kai the P bana khwaidagi henna fani haro. So sir kumaktre. So zainaro. Yarabo.
E would
Sigi sika. Kayumba haziki this to the nang na suppose let's say see this is the nang force either see the P bana phagadra color to pasina ge ka. 1 second. I hazik next question do gini ko na ja force nang na see the P bana phagadra see the P bana phagadra see the P bana phagadra sineba. Maximum acceleration put ho an ge haragade. Adu report se kayumba nang na see the P ragadi kayam kana kanaroi nang na kayumba see the P ragadi Idorogani have the port C rotate towning and is chaining and see the piragadi rotation the layer or just friction katang layer ni buka. See the piragana kadoni hamatam the mazi rotation kartu na torane hatai. So option C karamana yengzim tang option guys let's figure out karamana chikida solid sphere. H ina kayumba R the piragadi maya the P bane buka maya the piragadi port C rotation le hellaroi buka duna A zima yararoi H is equal to 2R matun the piragadi rotation di layrani but magi kedoba kaino duti maraki zidi maraki ka B zika 2R H is equal to 0 0 ga 2R ga mathaka 0 ga the P with no relation between H and R for maximum acceleration of center of mass magi acceleration the maximum when garagadi animax mazi rotation as well as translational motion the p gadonebako but mazi kai the p bena quite the phase in force ka dana magi total energy doko total energy the token v kaina quite funny sigisi question number 91 se kitang kaina to khanbam changi ko question number 91 c you need to think moina question number 91 sida high c kaino have the there is kai have a solution smooth horizontal surface na ma high ribu common is the sorry CR question is the smooth yone is the smooth horizontal surface hybra hi de hi bro kaino kanam ko mukti adu smooth horizontal surface haragadi sigi is a trick ne ko ina sigi smooth horizontal surface miss to hore dugini smooth se palam jagadi kaino ne ko we have the rotation na mathakta pibana rotation layrani ko duga makhada piragadi kanadre may aduna mathakta pibana khwaidena farni kaigumba ajiki smooth to hiram butaragadi ko so 1 second ignore him to talk ko right fine so aduna kai we have smooth hiram ni rotation layer roiba adi rotation laytaba taragadi noina potsi kaina habda pot ama sumaina si lebsida sigi smooth si nang na force am pireba rotation layer roidam ni na nang adi kedoba sumaina si sida piba chap manai ne nang sida pigera si pigera loin chap manai si kedoba slide to godoba neba or glide hagdra adum sliding to drom neba awna nang sida pigera smooth oiram ni na maji friction later smooth surface to the rolling to bosunya ya deba ko smooth horizontal surface study there cannot be any rolling motion aduna kedoni ha matamda anywhere regardless nang pangpi de adum pi anywhere pbr ni ko so option number d will be the right answer gyan taita de
Tai sir.
Smooth wave ko smooth means kaino no rolling motion no rolling atar yan tai ko aduna adum it is kaido regardless of where you give the force ko eir ko. Now next thing this is rolling, the velocity of its center of mass is her VCM. Which one will be correct? And I have a call. This summer roll to the velocity of the highest point to adudu and at point of contact ki velocity is 0. No point of contact ki magi velocity is opposite side to chalani amana front side to chalani ka. Point is VCM and at point of contact is VCM. Is VCM. Okay. My center of mass the velocity of highest point is 2 VCM and point of contact is BCM. The velocity of highest point is 2 and point of contact is 2 VCM. No, alright. Point of highest contact is 2 VCM. Sibudi are aduga and at point of contact is 0. Okay, so I think option number A is the right answer. Sige. Option number A is the Gyan Sorry. Yarabo. Kayino ka ang kumagtize. Amtanga haisira. Okay. Loidore ka pung zu ayore. Pung tara tagidore nga si. Asidi pasare tois. Anyway, this kamale na ko this roll to matamda magi kedoni have the C point C magi velocity amale any velocity is let's say C1 and high C is the mazi rotational velocity at tangential velocity amale ni na C V2 neva and then whole system gi velocity is whole system ma ko this among man ni ko whole system gi velocity is VCM neva ko aduna kedoni ha matamda again magi mathaki se v1 z kaina the VCM plus harga omega r ne ko omega r. So omega r do di amka kai oini have the c so dum pcm or ne aduna 2 vcm or ne ko. And then v2 zidi kai no have the vcm minus v minus omega r right there. Minus omega r. So the vcm minus omega minus vcm right there minus vcm which is equal to 0. Gyan tadabra? Ngaubra? Kayino kanang kumagtriza. Yarbo Lakshmi?
Hi, sir.
Yare ko. Nikhil yare ko. Chetur jukumo ko. Prithivira that kramalema. Thingja lakpazida. Okay, fine. So question number 93. A solid spherical ball rolls on a table ratio with rotational content into total content energy putho. Yani ko 93 ja. 93 singa mudra Lakshmi.
Sir.
Question number 94, 95, 96. A solid sphere disk, this and solid cylinder, all of the same mass and radius are allowed to roll down on the inclined plane. Then, kanana khwaidagi han yauni have the magi radius of gyration khwaide pick paduna han yauduni ko. Auna disk ka solid cylinder gadi chap manani aduga solid sphere na khwaidagi han yaurani aduna solid sphere reaches the bottom first. Option number 8 aramani 94 se ko. Yengo yung kay tagi yung 94 se. Tabra? Taiko. 95. The speed of a homogeneous solid sphere after rolling down an inclined plane of vertical height h from rest without sliding is, and I have other things I do kaino have the my speed kaino have the z kaino gh by 1 plus k square by r square and gh by have 1 plus k square by r square do hapsal do go dum tarani khangbra sir nai se 95 se root over gh by 1 plus k square by r square do khangbra do da.
Sir.
Okay, 96. The last question. A solid homogeneous pair of mass m and radius moving on and partly rolling by. During this kind of motion of the sphere, total kinetic energy is conserved. The angular momentum of the sphere about the point of contact with the plane is conserved. Only the rotational kinetic energy about the center of mass is conserved. Angular momentum about the center of mass is conserved. Homogeneous pair of mass m and radius is moving on a rough horizontal surface. Aduna mazi rough horizontal surface samada mazi roll tawrineba ko, partly rolling and partly sliding. Audi mazi kaino si tawriba ko sitpam ji yawriba aduna magi angular momentum ji kashumta conserve oiroiba. Kayino ay matamda external torque amala kanima sitpam yawina. Ano my angular momentum conserve tawroi duga rotational kinetic energy about the center of mass to conserve the angular momentum to conserve the total kinetic energy d is conserved. The angular momentum of the sphere above the point of contact with the plane is conserved by skidding the one in a sliding the wind toroid. Only the rotational kinetic energy about the center of mass is conserved and have a car. So question number 96 is a little tricky way. So kay oini hamatam damasi only the rotational kinetic energy about the center of mass is conserved. On rotational magi angular velocity to taptharakani ko aduna rotational kinetic energy is conserved for angular momentum of the sphere about the point of contact with the plane is conserved and have a car. About the point of contact with the plane have okay. This question is a little tricky. About its kedova kano idea the angular momentum z again it's a rotational physical quantity in rotational motion angular momentum about its axis height deva adu the neva moina question tricky or angular momentum kedova about the point of contact aduna this is a little tricky question. Homogeneous pair my angular momentum about this point the angular momentum do kayo any conserve when you have see m into v square part my rotation to would become count or but radius moving rough and partly rolling and partly sliding So during this kind of motion, okay, my angular momentum d I d kem kai di I didn't change story ko I, and then my omega angular momentum so I omega 0 dum ta le ni yan da bra. So this option number B je ta ni kai no my angular momentum jo over 0 ta ne ba kyan dai ta de Lakshmi kyan ta bra Lakshmi
Tade,
kyan ta
sir.
bra ha
Tahouder, sir.
ta ho je ba ka set or ke ka about the point of contact is equal to 0 adum 0 oi lai ni ba kai you know have the L lai di kai no L is equal to mb na tra m budi are but magi sorry mb di kai no ne ba sorry my I omega ne ba I omega ne ba I budi are ba I di am lai jar ne ba but omega di kai no omega di 0 ne ba omega is equal to 0 kyan dai ta de magi solid sphere ni na ngasai gi solid sphere gi di kai we ni have the sida lai bu 2 by 5 m r square plus m into r square tan is 7 by 5 है 7 by 5 mr square into 0 which is equal to 0 adum 0 ta lai ne kyan dai ta de haro
Tarani, sir.
kai you know have matam da mana putho have angular momentum je about the point of contact have ne about this point never not about the center about this point the angular momentum the d kai no have the I is equal to koina kai khang have the I is equal to ICM plus m into d square na tra auna si tare ba auda again magi omega the kai no magi respect the si gi pot si rotate chung tau de ba magi akoi bi da rotation lei bro lei ti na auna ke dong ne have the 0 ta ne ba gyan tai ta de yarbo
Oh, sir.
okay fine so adudi nasigi class si sidalo shalasi ka thank you for the class ka okay fine so thank you for the class
Thank you,
and
sir.
okay fare ka so haying gi test so pan thado ka all the best all the best for tomorrow's test Nikhil all the
Thank you,
best ka
sir.
okay fine good night